Welcome to a video about IV fluids. In this video, we're going to be looking at IV fluids that do not contain medications. Rather, we're looking at IVs that contain salt and sugar, which are some of our common IV fluids. The questions that we're going to be asked are how much sugar? And sugar in an IV fluid shows up as dextrose. So how much dextrose is in the IV? The second question is how much salt, and when we're dealing with an IV, salt is often referred to with its chemical name as sodium chloride. Now both salt and sugar are solids, they're not liquids, but once they're dissolved in the IV, they become part of the IV fluid. However, because they are solids, we need to measure them in grams rather than in milliliters. Let's take a look at an example. Here we have D5W. That is the abbreviation for 5% dextrose. So you see that the D5W is simply referring to the 5% dextrose. And our question, just like I told you, is how many grams of dextrose are in the bag. Normally when we deal with a percent problem, we can take the percent times the total. And 5%, we'd move the decimal 0.05 times the total of 150 milliliters, and we put that in our calculator and we get an answer of 7.5, and we would guess that the label would be milliliters. The problem with this is that it is sugar, and sugar is a solid. It needs to be measured in grams, so this does not give us the right answer. Instead, what we have to use is that percent measure is defined a certain way, and all of our IV fluids are percent measure problems, and they are defined to be the number of grams per 100 milliliters. And so instead of using a traditional method with a percent times a total, we're going to set up a proportion. So the 5% means 5 grams per 100 milliliters. We're asking this question how many grams, and we have a total IV right here, is our total amount of 150 milliliters. So we do the math, we cross multiply, and we have 100x is equal to 750, and I divide by 100 on both sides, and I get x equals 7.5. Now that's the exact same number that we had. The difference is that this time we have the correct label. From our proportion we have a label of grams, and we know from what we've done in this problem that it's grams of dextrose. So by using the definition of percent measure that we have up here, we actually come up with an answer with the correct label for the problem. Let's try a second example. Again, this is a dextrose problem. This time it is D10W. So that 10 is referring to the percent, and we see that here on the bag. So this time it's 10%. Again, it's an IV fluid, so it's a percent measure problem. So that means 10 grams of dextrose per every 100 mLs. We want to know how many grams of dextrose are going to be in the entire bag. Now it's not the best picture, but over here is the total volume, and although it's not 100% clear, that would be 250 milliliters. So I've set up my proportion. I solve by cross multiply, so 100x is equal to 10 times 250, which is 2,500, and I divide both sides by 100, and I get x is equal to 25. I look back at my proportion right here. I see my label is grams, and I was solving for the grams of dextrose. So by setting up the percent measure problem based on the definition, I come out with the correct label at the end of the problem. So that's two examples of sugar. Now let's take a look at salt. One of the most common IV fluids is normal saline, and this abbreviation NS for normal saline refers to sodium chloride that is at 0.9%. Again, this is a percent measure. So I take the percent, 0.9, and that's my grams per 100 milliliters. And the question asks me how many grams of sodium chloride are in the bag. So I put X grams, and I want the volume for the whole bag, so I see that up here, and my volume is 1,000 milliliters. That gives me a proportion, so cross multiply 100x is equal to 0.9 times 1,000 is 900. Divide both sides by 100, and x is 9 grams is my label, and I see that in my proportion, and this time I was solving for the grams of sodium chloride, so I have 9 grams of salt. Let's try another common IV fluid with salt, and so this is half normal saline. Now many people want to confuse this half with a percent, but it's not a percent. You don't see a percent sign with it. We definitely don't want 50% salt. That would be awful. So this half is referring to that it's half as salty as normal saline. So if I take the 1/2, I look over here, normal saline, previous example, was 0.9%. Half of that is 0.45%. So again, it's a percent measure problem, so I take 0.45 as my percent and make that the grams. I put that over 100 milliliters because that is the definition of percent measure. And again, my question, how many grams of sodium chloride are in the bag? Volume of the bag given up here in the corner is 250 milliliters. So I have a proportion. I cross multiply. 100x is equal to 0.45 times 250, and I had to do that on my calculator. Got 112, excuse me there, 112.5, and divide both sides by 100, and I get x is 1.125 grams. I get my grams from my proportion, and I was solving for sodium chloride. I hope that these examples help you understand how percent measure problems are just slightly different from traditional percent problems because we need to end up with a label of grams for the solid substances that are in our IV bags.